Welcome to Megasquirt Training Part 13. In this video, we're going to be taking a look at our ignition timing table and modifier tables. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and talk about our spark timing table and our modifier tables. So when we want to go in and tune our spark timing, we're going to be using this main spark timing table. It's going to be based on load and engine RPM. It's going to be very straightforward to tune. We're going to be taking a look at how to do some editing in our main spark timing table as well as our modifier tables. Now our modifier table is going to be based on engine coolant temperature and intake air temperature, and they're going to be allowing us to offset our spark based on whatever kind of conditions we're going to be running our engine in. So without further wait, let's jump into the video so we can check this out. Okay, so let's get started here. We're going to be taking a look at our ignition timing table and our modifiers in this video. So this is going to be looking at how the Megasquirt is going to work with our spark timing and all the details that we need to know. So the very first thing we're going to be doing is jumping into ignition settings, and then going down here to ignition table 1. This is going to be our main spark timing table. Now in this configuration we can see that the load input here is going to be the kPa or the map sensor input, and we're going to be finding it goes from 100 kPa down to 20 kPa. We're able to edit the breakpoints however we like, and we can see that the bottom row here is going to be on the engine RPM. So it's going to be very similar to our main fuel table, depending on how our fuel strategy is going to be set up here. If we go into fuel settings, main table here, we can find that the breakpoints on our fuel table are going to be virtually identical to the breakpoints here on our ignition timing table. Now it should be noted that the fuel table has more data points in it than our spark timing table. So if we're comparing how many data points we have here, we have more in our fuel table. So one thing I want to point out here before we go any further, we are able to have different load inputs to our ignition timing table just like we found in our fuel table. If we're looking at those different fuel strategies, this is going to be in speed density mode, so we can see our fuel load is in kPa. That's reading from our map sensor, speed density mode. We're also going to find that we have that percentage baro where we compare the baro pressure to our map pressure, and we're going to be finding that it's going to be reported in our fuel load. Now, there's no reason to set our ignition timing table up like that. And when we were in our TPS mode, in our alpha N, we found that it reported percentage throttle. And again, we may not want to set our ignition timing table up like that, but in most cases, we're going to be finding our ignition timing is going to be referencing just our map sensor, regardless of whatever our fuel strategy is showing here. But if we wanted to change the load input to this table, and we had wanted to go in and set this on something like throttle position, if we jump up here into our engine, or it's a general settings, we're going to be finding we have this primary ignition load, and this is going to be specifying what this table will be set on. Right now it's set on speed density. If I click on this, I go here and I could set it on alpha N, and I could have my main fuel table set on my map sensor, and then my spark timing set on percentage throttle. Now, normally you're not going to do this. You're going to be setting again your table on speed density or map sensor mode. We can see that when I do that, it's going to go change the load input to the axis here. But I wanted to point out that if you're going to be changing that, it can be done right here under the general settings, and we're not going to be doing it in another location. Let's click burn here and click close. So we're going to be seeing that if we want to edit the breakpoints, if we have a turbocharged engine, and we're going to be getting into positive manifold pressures, we have to compensate for that for our spark timing, and obviously anything above 100 kPa, it's not going to characterize that. So we'd have to go ahead, we just simply click on the breakpoint, change it to whatever we'd like. So if I had an engine that was running 10 pounds of boost, and that would be approximately 160 kPa, I might go and set my breakpoint here for 200 kPa. And then I would just go ahead and redefine my breakpoints here, do one at 180, do one at 160, do one here at 140, 120, 100, and then I'd redefine my breakpoints here in my table. I do one at 80, I do one at 60, I do one at 40, and I could even redefine them probably a little bit better here too. I could maybe go to 90, maybe go to 75, maybe go here to 60, 50, 40, and 30. So we're going to have a bunch of flexibility. It's really as simple as that if we want to redefine and re-index our breakpoints for boost. Normally what I would suggest that you do is leave yourself at least 4 to 5 breakpoints here for vacuum, for spark. It's not going to be as critical in our spark timing as we found in our fuel table. We definitely want to have more resolution in vacuum, but in spark timing and vacuum, usually 5 to 6 breakpoints will be sufficient here. So make sure you're 100 kPa here and you have a couple breakpoints below this, so you can characterize your vacuum portion. But your boosted portion, if you're going to be running, let's say 160 kPa or 10 pounds of boost, you want to go ahead and definitely have some data points above that. You don't want to have that be your last breakpoint in the table. Can be typically going about 4 to 5 psi higher, which is 200 kPa. So 160 kPa was my target, let's say, a boost, or my desired boost, and I scale it out here to 200. Just in case the boost went a little bit higher, we would be able to pull ignition timing out. It's not going to be fixed at that last amount in the table. So that's something I want to point out. And we're also going to be seeing here at the top of the table, we want to make sure that the last breakpoint is going to be the same or higher than our rev limiter. So whatever that's going to be set at, if we jump up here to basic load settings and we go down here into our rev limiter, we're going to be finding we set a rev limiter here in this coolant-based limiter at 6,500. We want to make sure this is at least 6,500, if not 7,000, and we'd re-index the breakpoints here in our table. So pretty straightforward. Same thing if you wanted to re-index them, just simply click on it, type in 7,000, re-indexes it. But be aware when you do that, it will be changing your spark timing. So I suggest that you set your breakpoints up before you do any tuning for both load axes, just like our field table, so you don't have to come back in and go through and tune a particular area that you might have changed a breakpoint in, just something that you want to kind of keep in mind. Now, if you are going to set up your ignition timing tables for boost, you obviously see that I changed my breakpoint, but my values in the table didn't change. We do not want to run this as much ignition timing. So when we're working with our spark timing maps, we're going to be using a plus or minus adder to the table. So if I want to go ahead and take a bunch of ignition timing out, I hit the minus key. That's going to go ahead and subtract from the cells. I would go here and maybe do something like 15 degrees. I might even want to go even more than that. Like click minus again, do something like another 8 degrees. We want to be very, very conservative because we're starting off and we don't want to blow our engine up. So what I would do here to kind of blend the changes in, I'd grab all these values here, I'd highlight them all, and I can see I'm starting at 90 kPa and going all the way up to the max breakpoint. I'd use my interpolate function. Hit the interpolate key, and then it interpolates the values. And we can see now to drastically reduce the values here. If we wanted to just do vertical interpolations and kind of blend this back in, maybe it was too aggressive, we could just simply do it one by one here vertically and accomplish this similar kind of task. If we're kind of populating some values in the spark timing seems to be the one thing that a lot of people are afraid to touch because it can blow the engine if you're too aggressive with it, and it's very intimidating as a novice tuner that you're trying to kind of sort out things. I can tell you from experience, normally at idle conditions, so from 700 to 1200 here, let's say from 75 kPa and below, having a value between 10 to 15 degrees, if we use the equal sign, it's going to allow us to populate a fixed value here. Having something between 10 to 15 degrees on most engines will go in and allow us to have, let's highlight that again and try that again, equals 15. Now we can see it changed it to 15. This will allow us to have a decent idle to start with. Now if you have a big cam installed, you're going to have to get some of that torque you lost back with a cam at idle. You're going to increase the values here in your spark timing, and you're going to be watching what your map sensor reads in vacuum. Ideally, you're going to be adding as much timing in here to get your map sensor to read the lowest vacuum possible. It's going to signify you're getting closer to maximum brake torque. That's one strategy to go and dial in your idle timing. And as we go up into the table here, we get up into engine RPM. If we had something like 1500 at 1200 RPM, 15 degrees I should say, 15 degrees timing at 1200, we want to blend this back into the table here. We want to go here, grab these values, the interpolate. And then when we're in our cruising condition, so from 2000, let's say, on up to 7000, we could have a value here of at least 30 degrees. Let's go equals 30. And then we might want to blend these changes back in the table. Let's highlight this, kind of do a blend function. And there we have a spark timing table. Pretty straightforward. Now the ignition timing we have up top here is probably too much. Looking here, going across our load row here at 160 kPa, we can see a value of 10 degrees, and most all engines will be very conservative. And we can see it has a tapering effect as we go for here from 2600 at 10 degrees, and as we go up here, it goes up to 21 degrees at 7000. That's a pretty large step in ignition timing. We may not need that much step. That might be too aggressive. So what we could do here, just highlight this row, Control-C, copy it, go to the 7000 RPM column, Control-V, paste it, and then go ahead and highlight this whole area here and just use this interpolate function, and it'll go ahead and it'll just draw a straight line across that. Now obviously that probably is a little too conservative there, but you get the idea of being able to utilize this and doing your interpolation functions. So if we went in and made some kind of a change like that, that obviously was something undesirable, we could use this undo feature. So we can click this and we can see that we undid that, or we can redo. So we have these options here at the bottom, which is really nice if we're just kind of making a mistake like that. We don't want to be as aggressive. So depending on what we're doing here, if I wanted to do a change like that, I might just go here, Control C, go here, Control V, paste, and just build out the table like this. And this will be definitely a nice ignition timing table for most engines that are going to be a stock engine, maybe with a turbo kit on it or something of that nature. So we could have something like this. But this will get you started. It'll definitely be something that it will be conservative enough that you should be able to run the engine with 0 issues and boost. And we're going to burn that to our ignition map. So we're going to be seeing that we have that ability to either use the interpolate function, or we're going to be using a plus or minus, or using the equal and setting the ignition timing as a fixed value. That's going to be the most useful ways to edit our table here, and that's going to be how I always do my ignition timing table with the Megasquirt. So now that we've looked at our spark timing, let's make this really simple. You're not going to be doing this, but I'm going to do this just kind of do for illustration purposes. I'm going to go and set my entire table here, use the equal sign, set it to 30 degrees. Now I have a reason I'm going to be doing this. Again, you are not going to want to do this, but if we look here, our ignition advance is reported at 30 degrees. So my gauge is displaying 30. We know what my ignition timing is at any given load range here, RPM. It's going to be a fixed value. Now I'm doing this to illustrate the next things that we need to look at here. Let's click burn real quick, and let's go ahead and take this out. And we're going to be going into our manifold air temp base timing retard and our cold advance. These are our modifier tables for our spark timing. And depending on if we're on a cold engine warming up, or if we're on a warm engine and we're starting to get into hot air temperatures, we have to have a completely different way to characterize our ignition timing and have a modifier effect. So let's go here. I'm actually going to power cycle. It's needing me to power cycle because I made some change it wasn't happy with. Let's go ahead and power cycle back. So I have up on my gauge displays here my manifold air temp retard and my cold advance. Now these are going to be reporting what comes from our tables here. So let's jump into ignition settings. Let's look at cold advance first. So we're going to be seeing this table here. It's going to have coolant temperature here on our left-hand side and offset here on our right-hand side. This is going to be a modifier table. It's going to be adding ignition timing when our engine is cold. So on a cold engine, we typically want to add more spark timing. It's going to help the engine fire off and stabilize. It's going to produce a little bit more torque from the engine, and it's going to allow the engine to warm up a little bit quicker. So they're all going to be added benefits for running a little more spark advance. Now we want to make sure as we get up to the hotter temperatures that we want to zero out the table. We do not want to have a value in here. Let's go ahead. I'm going to pop a value of 2 in there and actually go in here and let's highlight the whole table here. Let's add another value of 2. Click burn. And we can see when we do that, it adds 2 more degrees to our overall advance. Now remember, our ignition timing table is locked at 30 degrees. So what I've done here is added 2 degrees over my entire spark timing table globally. We don't want to do that. That's going to be something we definitely want to avoid. So we want to make sure that our values in our table here at the warmer temperatures, usually around 130 and higher here, let's click burn, are going to be left at 0. That's going to go and put us right back to the spark timing from our table, whatever that's going to be at. So whatever load and RPM we're going to be running at, we're going to be finding that timing is going to dynamically move all the time. It's going to be going in and not modifying that. But on the colder temperatures, let's bring our engine coolant temperature down here. Let's bring it down into something that's fairly cold. We can see the table here. They're showing very cold temperatures. We can see as we taper down, 30 degrees here. We have approximately between 2 to 3 degrees adder in the table. We can see it's reporting here, 32.6. Now again, this is coming from my table that's locked at 30 degrees. So this is just an additive to that table amount. Normally, what I would suggest here on a cold engine, especially if you have a race engine with a bigger cam in it, you might find that something like 8 degrees is going to be something better suited for having your spark advance being an adder here. And then here, even at 40 degrees, 6 degrees might have, 40 degrees coolant temp, 8 degrees ignition timing, 60 degrees coolant temp, 6 degrees ignition timing, 80 degrees coolant temp, 4 degrees ignition timing, 100, we might do something like 1 or 2, click burn, and we're going to be seeing that we have a bunch more advanced. So you're just going to be adding as much advance to, again, stabilize the idle on cold, get the engine to warm up a little bit quicker, and you're going to be seeing if that has any effect. If it does not, you can run less advance, but typically speaking, you're going to be running a bunch of advance like this and setting up the table. So you're going to be seeing, if we scoot this out of the way here, that our cold advance gauge is reporting us 8 degrees coming right from our table. Based on that coolant temperature, we're here at around 30 degrees. That's, again, sourced right there. So we're going to be seeing that it's just simply an adder, and then as we come up in our temperature, let's go ahead and just simulate that one last time here. As we bring our engine coolant temperature up, we're going to be seeing that that tapers out and it drops out. And now we're going to be back into our spark timing from our main spark timing table. We can see our cold advance goes to 0, our spark advance goes to 30, report it from the table. Now let's shut this down here. We're going to see the opposite effect with our air temp retard table. So if we jump back up here to ignition settings into our mat-based timing retard, we're going to be finding that, let's actually open this window up a little bit, and we can see this a little bit easier here. We're going to be finding that we have this table here based on estimated intake air temp, and we're going to be finding right now our estimated intake air temp here is at 126, and we have this manifold air temp here on our left-hand side versus the retard here on our right-hand side. So it's going to be a way that we can reduce our spark timing as our air density goes down and that air temp goes up. It's going to be heating up our cylinder a bit more, and it's going to be making our cylinder more prone to knock. So we have to have this in place here to make sure that our engine is going to be safe as it gets the high intake air temps. And this is going to be especially important for a forced induction application. Naturally aspirated, we definitely want to utilize this, but it's going to be very imperative to use this on a forced induction, especially if you don't have an intercooler. It'll be even more vital. So we can see here, this table works pretty straightforward. As the air temp goes higher, it starts to pull more ignition timing. We can see here that our mat retard here is going to be displayed in 0 degrees. Right now, my advance is at 30 because I haven't applied anything, and we're not using a cold advance. That's at 0. So let's go ahead. I'm going to be bringing my air temp up here. We can see as I bring my air temperature, if you pay attention to my estimated intake air temp gauge here, as I bring my air temp up, it's going to be applying more ignition retard. And we can see at 220 degrees, 218, it's showing 4 degrees retard, but now my spark timing here is reduced by 4, showing 26 as my advance. Again, my table's at 30, it's locked there, but I'm showing here what my table here is reporting. So this is relatively straightforward to look at and to work with. I would probably be a little more aggressive with the application of this table. So we can see it starts off the breakpoint here at 160. I might go in here and set this to something more along the lines of 100 degrees. And go here and set this to maybe something like 120, then 140, then 160, 180, and then maybe last here at 220. And I would probably start to pull some a little bit of the intake air temp out here, maybe at something like 1 degree at 120, and maybe 2 degrees here at 140, and then 4 degrees at 160, 180, 6 degrees, 220, 8 degrees. Let's click burn, and we're going to be seeing now that at that lower temperature, it's going to be starting to pull just a little bit of timing out. You can see it's going to 29, pulling out 1 degree. We want to be a little bit more aggressive with this, especially on a turbo engine, supercharged engine, because we're going to be more likely to have knock and pre-ignition occur from not pulling out the spark timing as our air density goes down and the temperature goes up. So we're going to be seeing that that is pretty straightforward of how this all works. We have to be mindful that, jumping into our spark timing table one last time here, I've set the values all to 30 degrees, so it's very easy to see how these trims are being applied. It's very, very clear, and that's why I set it this way. Obviously, you will not be locking your entire timing table here, or spark timing table at 30 degrees. You're gonna have dynamic movement in your timing, so tracking what is going on is gonna be so obvious just looking at your ignition advance. You're definitely gonna wanna have to rely on looking here at the mat retard or the cold advance, depending on what kind of condition you're in. So again, cold engine, you're gonna be looking at the cold advance, and you're gonna be seeing how much it adds. When you get into the hotter temps, looking at your manifold air temp retard, you're definitely going to watch what this is doing so you can see if it's taking timing out. And you have to be mindful here, looking at either table, the last breakpoint here, make sure that it's at 0 because we don't want to be adding timing unnecessarily to our spark timing table at all times as a global adder. And in our manifold air temp here, the first breakpoint, we want to make sure that we have this at 0, whatever this is going to be at, because we would be going retarding the values from our main spark timing table. So it would be a global retard function. So the values here, even though they're a positive value, not a negative value, it'll be specifying ignition retard. That's the other thing I wanted to point out. If that was not clear already from seeing how this works, they're specifying that it's a retard amount in this column here. So pretty straightforward. It's not anything super complicated, but now that you understand where you're going to be looking for your modifiers for your spark timing and how the spark timing works, It's going to be pretty straightforward, and if you dial your spark timing table in like I showed you, you'll have a nice conservative map to begin your tuning with. Okay, so that wraps up Megasquirt training part 12. In the next video, we're going to be taking a look at working with our idle control. We're going to have a lot to learn, so I'll see you in the next video.